Good evening, guys, and welcome back. Tonight we're going to continue talking about solving systems of equation, but tonight specifically we're going to be looking at which method is going to be the best method to solve. Okay, so there's three things we're actually looking at in terms of what methods we have available to us. So if I'm looking at which method is the best method, we have to remember that there are three methods that we have. Let's just do this down here. We have the first method we talked about was graphing. And when we think about graphing systems of equations, we're going to make sure that both of the equations are in slope-intercept form, or solved for y. The second one that we worked with was substitution. And substitution is really important and necessary, actually, that one of our equations is solved for one variable. Whether that's x or y, it didn't matter at that point. As long as we knew that one of the equations was solved for a variable, we could then substitute what that was equal into the other equation and move forward. The third one that we've worked with is elimination. In the elimination method, there was the example where we had coefficients of one of the variables that were either the same or additive inverses. If they were the same, we were able to subtract the entire equations, and if they were additive inverses, we added them together. That was like an easier version. And then we had a more difficult version where we had to multiply either one or both of the equations to make additive inverse coefficients. And those are the three different methods that we're going to be talking about in terms of which is the best method to solve. Alright, let me scroll on down here. So example 1, we're going to want to write down example 1 in our notebook. And it is here. Example 1. The instructions tell us that we want to choose the best method. Go ahead and write this down. We have two equations. One is 5x plus 7y is equal to 2, and the second one is negative 2x plus 7y is equal to 9. As you're writing this down, I'm thinking about this system of equations, and I'm thinking if I wanted to graph it, I need both of these equations to be in slope-intercept form. Neither one of them is, so graphing is out. And then I think about substitution. Are these in a format in which it'd be easy for me to solve for one of the variables, or is one of the variables already solved for? And no, one of the variables isn't solved for in one of the equations, and all of the coefficients for the variables are something other than 1, meaning I'm probably going to have a fraction. It's not going to be nice. So I'm thinking about the elimination method, and I look and I can see that the coefficients for y are both 7, so they're the same, which means this is going to be an easier form of the elimination method. So right up here, I'm just going to write, I'm choosing to use the elimination method. Okay, the reason why I've chosen that is because I see that the coefficients for y are the same, which, if they're the same, that means I'm going to subtract this system, these equations in this system. So I have 5x plus 7y equals 2, and I'm subtracting the completely other equation. So I've got 5 minus negative 2. And I'm going to do that to the side here. I've got 5x minus negative 2x. When I subtract the negative, it becomes positive, so I have to remember, and I can just decide if I'm unsure. 5 plus 2 is going to give me that 7x. 7x, and then I know that 7 minus 7 is going to be nothing. 7 minus 7 is nothing. And then 2 minus 9. So I have 2 minus 9. That's going to be equal to negative 7. So for this first example, I can just go ahead and continue by dividing both sides by 7. And I have x is equal to negative 1. I'm going to write that as my x coordinate in my ordered pair up here. So if I think that x is equal to negative 1, I know the next step is to go ahead and substitute that negative 1 in for an x into one of the equations, the original equations. And which one do you think I want to use? Now, I'm not sure exactly what you said, but I think I would choose this first equation because all the coefficients are positive. It just looks a little bit easier. Again, I can do either one. This one just looks like it'll be a little bit easier to do. So I'm going to say 5 times negative 1. I'm going to change that to red. Plus 7y equals 2. I'm just going to solve this for y. So since it's negative 5 here, plus 7y equals 2. I'm going to add 5 to both sides. I need a little bit more space. And I have 7y is equal to 7. Divide both sides by 7. Lots of 7's here. Y is equal to 1. So I think here x was equal to negative 1 and y is equal to 1. I'm going to have to just double check to make sure that this is my answer. And I do go ahead and I do that again by substituting my x and my y values. So here's my x, here's my y values into the original equations. I have to do to both because this ordered pair should be a solution for both of the equations. It's possible that you just find that it's equal to 1, or it's a solution for one but not the other. In that case, it's not a solution for the system. So I'm going to start by saying 5x plus 7y is equal to 2. And then I'm going to check these. 5 times negative 1 plus 7 times 1, I think, is equal to 2. And in fact, I have negative 5 plus 7 equals 2, and 2 does equal 2. So it works for this first one. And that's great, but it has to work for the second one as well. So negative 2x plus 7y is equal to 9. And this is negative 2 times negative 1 plus 7 times 1, we think equals 9. And this is 2 plus 7. We know that equals 9, so we're good there. Great. So we chose the elimination method because the coefficients for the y were the same. It makes the most sense to do that one there. And then we checked to find that our solution is actually negative 1, comma 1. Okay. Graphically, that's where those two lines intersect. Let's take a look at example 2. Write this in your notebook. We have 3x plus 5y is equal to 2x, and we have 2x plus 2y is equal to 16. So I'm looking here and I'm thinking, is this a typo? And I'm thinking, which is the best method to solve here? And in this case, I want to start by combining the like terms of this first equation. So I'm going to pull this up here and do this with me. So here I've got this 3x plus 5y equals 2x. I'm going to combine these like terms so that I can say I have this. So here I have x plus 5y equals 0. And x plus 5y is equal to 0. I see this has the x has a coefficient of 1, meaning I could subtract 5y from both sides and substitute. Or I could multiply this whole equation by 2, and then, or negative 2, and then use the elimination method. I think either one of those would work for this one. Since we did elimination for the last one, I'm going to say substitution is the way to go for this one. So I'm going to say substitution. Because I'm choosing substitution because this x has a coefficient of 1, and so to solve this for the variable x, I'm just going to subtract 5y from both sides. And I know that this first equation is going to be x equals negative 5y. I'm going to go ahead and substitute that now into that second equation. So let's go 2x. Instead of the x, I'm going to substitute in negative 5y. So pulling this down, plus 2y is equal to 16. This is negative 10y plus 2y is equal to 16. So this is negative 8y is equal to 16. And divide both sides by negative 8. Y is equal to negative 2. So up here, I'm going to say my y value is equal to -2. And I'm going to substitute this back into either equation. I'm going to guess this second equation is going to be the way to go. It just looks easier. So I then have 2x plus 2, and I said that y is equal to -2. Equals 16. And we'll solve. X equals 10. X equals 10. So I think that this is now my solution to my equation. I'm going to do just a quick mental check here. If I do that, I think, so 10 times x, this would be 30 plus -10, so that's 20, equals 2 times 10 is 20, so it works for this one. And then 2 times 10 is 20 plus, it's -4, so 20 plus -4 is 16. Good, so my solution here that I was able to check mentally is 10, -2, and that works. Notice I'm checking these either written or mentally, but I'm going in and I'm checking these before we go on to the next example. And so here's our last example for today. It says Sarah bought 4 t-shirts and 3 pairs of jeans for $181. Jenna bought 2 t-shirts and 2 pairs of jeans for $110. Remember, when we have a word problem, we're going to start by defining our variables. So let's say x and let's say y. We know the number of t-shirts, but we don't know the cost of t-shirts. So let's say x is our cost of t-shirts. And let's say y is our cost. We know the number of pairs she's getting, but we don't know the cost. So the cost of her jeans. Now if we do this and we make our equation one for Sarah, this is going to be 4x plus 3y is equal to 181. And this represents Sarah's total cost. And then we can go ahead and do one for Jenna. So she bought 2x plus 2y equals 110. And this one's Jenna. So I'm looking at this pair of equations I have, this system, and thinking to myself, which is going to be the best way? Which method? Graphing, substitution, or elimination? Which one do you think? If you said elimination, I agree. And the question that you're going to see on an IA or on a test is like, why would you then choose elimination? And you're going to be able to have to articulate that we're choosing elimination because they're both in standard form, and I can easily multiply these two coefficients to get an additive inverse. So what we're going to want to do here is I'm going to want to leave the first equation alone. I'm going to want to multiply the second equation to get the additive inverse of 4, which is -4. So 2 times -2 is going to give me -4. So I'm going to multiply. Let me just check this here. I'm going to multiply this second equation completely by -2. So I'm going to then distribute that -2 to each one of the terms, just like we did yesterday. Here's my first one. This is Sarah's cost. So Jenna's cost is going to be -4x minus 4y equals -220. Since the x coefficients are additive inverses, I can just go ahead and add. Remember, additive inverses, I add equations together. 4x minus 4x is nothing. 3 plus -4 is -1y. 181 plus 220. the same thing as subtracting 220 from 181. So I'm going to do this. So I find that negative 1y is equal to negative 39. And so y, when I divide both sides by negative 1, is equal to 39. What does that mean? That means that the cost of each pair of jeans is $39. So I've got something for x, and I know y is equal to 39. I'm looking back at one of the original equations. I'm thinking, which one can I substitute back in to find the value of x? And I'm going to guess the second equation. So I have 2x, I don't know, plus 2 times 39 equals 110. Let's solve for x by first combining our constants, our like terms, or sorry, multiplying 2 times 39. So it's going to be 2x plus 78 equals 110. Subtract 78. And I find that x is going to be equal to 16. Let me write that back up in here. And to finish out tonight's homework, your task is going to be to double check and make sure that our answer is 16, that our answers are 16 and 39, meaning that the cost of the t-shirts are $16 each, and the cost of the jeans are $39. Go ahead and check these solutions, check these values to make sure they're a solution, and then wrap it up, and I'll see you guys tomorrow. Have a good night.